All right, everyone. So now we're into Unit 2. This is going to be the next part of the study guide. I highly recommend, if you have not already gone through Unit 1, really doing so, because being able to calculate molar mass and use molar mass in a T-chart is absolutely required for solutions. Chemistry builds upon itself. So we're going to start with skill 1 from Unit 2, which is molarity. And we kind of broke it down into just solving for molarity and then solving for the other units that are in there. So molarity is a measure of the concentration of the solute particles in a solution. So how much of your solute is dissolved. If something has a high molarity, like a large number, that means that there are a large number of solute particles dissolved, and it's the ratio of the moles of the solute to the liters of the total solution. So basically a ratio of amount to volume or space. So if you have a high molarity, that means it's really dense. There's a lot of molecules in there. It's kind of crowded is a way to think about it. And the formula looks like this. Molarity is a capital M, which I didn't actually include that in your study guide. So molarity is represented by the symbol capital M, and it's equal to your moles divided by your liters. And so that can be rearranged so that if you want to solve for moles for your problem, that would be your molarity times your liters, or liters would be equal to your moles divided by your molarity. And so you can kind of use this formula to calculate multiple things. Now, one thing that I would like to remind you is that grams can be used in these problems because you can change from grams to moles using your molar mass, which is a skill that we learned in Unit 1. So the expectation is that you can take that skill and use it again in a later application. So if we look at this first question, it says, what is the molarity of a solution prepared by dissolving 100 grams of beryllium chloride in a 2.1 liter solution? So again, we want to label what we're given and what we're looking for. So I'm going to kind of create like two little columns here. So our numbers that we're given 100 grams of beryllium chloride, and we're given 2.1 liters. And we're looking for the molarity. Okay, it says what is the molarity. So when we think about this, okay, molarity is what we're looking for, so we're going to use that first formula. M is equal to moles divided by liters. Okay, well, I know what my liters are. It's 2.1 liters. However, we don't have moles. We were given grams. And so that means we're going to need to change our grams into moles before we can put it into our formula. And that's why it's really important to write down your units, because if your units don't match what your formula is, you know that you need to make a change. So before we can do that, we need to calculate the molar mass of beryllium chloride. And so we know that we want to split up our elements, and we want to use our periodic table to get the molar mass of each of them. So when we do this, okay, we have one beryllium atom and two chlorine atoms. The atomic mass or molar mass of beryllium on your periodic table is going to be 9.01. Chlorine is 35.45. So we get 9.01, 70.90, and I kind of run out of space below it, but when we add them together, you're going to get 79.91 grams per mole of beryllium chloride. And so what we do is we then take our given, which is the number of moles, the number of grams. We have 100 grams of beryllium chloride. And we know that this fraction can be written as 79.91 grams of beryllium chloride over 1 mole of beryllium chloride. But since I have grams of beryllium chloride here, that means I need it at the bottom, so I'm really going to end up flipping my fraction so that the 79.91 grams of beryllium chloride is at the bottom, and my 1 mole is at the top. So we multiply by 1, divide by 79, and when you actually do this in your calculator, 100 divided by 79.91 is 1.25 moles of beryllium chloride. Now, I have seen so many students make this mistake where they're like, cool, I did my T-chart, now I'm finished. Except our answer, they did not ask how many moles are there. They asked what is the molarity. So then you need to take your moles and plug it in to the blank spot in our formula to where we put 1.25 moles here, and we actually then divide and we say, okay, 1.25 divided by 2.1 gives us 0.60 molar beryllium chloride. So your unit would be that capital M, and you use your formula. And that is how we solve for that problem. Now, that's just solving for molarity. If they give you the moles, then you don't have to do the molar mass in the T-chart. You just moles divided by liters. But if you are not given moles first, you have to change your grams into moles before plugging it in to your formula. And now we can look at the second skill in Unit 2, which was solving for either volume or moles. Like, what if they're not looking for molarity? So in this question, it says, what is the volume in liters? Okay, so we know that when we label what we're given and what we're looking for, that we're looking for volume. We want to know what is the liters, right? That's our question. That is needed to create a 3 molar solution. So we're given 3 molar, and we've got 1.5 moles of FeCl2. Now, since they gave it to me in moles, I don't have to worry about molar mass or converting or anything like that. And since we want to know what our liters are equal to, we can use this formula right here. So liters is equal to moles divided by molarity. And we know that our moles is 1.5 moles, and we're dividing by 3m. And so 1.5 divided by 3 is going to give you 0.5 liters. And you're done. And that's it. So it's labeling what you're given, figuring out what you're looking for, and choosing the right formula. And speaking of formulas, our percent by mass. Okay, this is the last real math part of Unit 2, so we're just kind of doing it all in one video. But percent by mass is the percentage of the solute that is in the total solution. So earlier it was kind of the ratio, but here we're talking about just percentage. And remember that your solution is going to be made up of 2 parts. You've got your solute and the solvent, which is usually water. So as a vocabulary reminder, solute, that's what's being dissolved. So if I'm making Kool-Aid, the solute would be the sugar, the Kool-Aid packet. And the solvent is the water. That's what's actually doing the dissolving. Now, the formula for percent by mass, so we would say percent mass, is equal to the grams of our solute divided by the grams total solution, okay, multiplied by 100%. Now, one thing to keep in mind is that your solution is your solvent plus your solute. So if it's not already added together, you'll need to do so. And don't forget, percent signs never go in your calculator. So let's look at the first question. It says, what is the percent by mass of a solution that contains 150 grams of magnesium chloride and 300 grams of water? So when we look at this, we see that here they're telling us we have grams of water. Remember, water is usually our solvent. So you kind of want to label for these problems, what do you have? Do you have your solution, your solute, your solvent? What are your pieces? And then magnesium chloride, your chemical, that's always going to be your solute. That's what's being dissolved. So in this case, when we look at our formula, our percent by mass is equal to the grams of our solute divided by the grams of your total solution times 100. Well, we know that our grams of our solute is 150.0 grams of magnesium chloride, which that should have a subscript 2, typo there, divided by the grams of solution. Well, notice we have solute and solvent, so to get our solution, we'll need to add those together. So we're going to have 150.0 grams plus 300 grams, okay, total, times 100. And to simplify, we've got 150 grams of magnesium chloride at the top, and we're going to have 450 grams of magnesium, total solution times 100. And remember, please actually take your time, write it all out. Show all of your steps, even if you think it's obvious, because if you make a mistake, you want to have it written down so you can get partial credit. So when we do this, we get 33.3% magnesium chloride as our answer, because it's 150 divided by 450 times 100. And so we can see that again for question 2, if we look at another example, which I highly recommend pausing the video, trying question 2 on your own, and then pressing play. But I will walk you through this one. So it says, what is the percent by mass of a solution that contains 500 grams of calcium phosphate in a solution with a total mass of 750 grams? So here we've got our solute, but that word total, or if you were to see the word solution, okay, this is our total grams of solution. So that means it's already added together for us. We probably have about 250 grams of water. So when we look at our percent by mass, it's literally going to be, and notice I'm writing down my formula every time, because even if you mess something up, okay, if you can write down hey, I know I need to use this formula, that means you're demonstrating at least a small understanding of what you're supposed to do for this problem. So we plug in our numbers. Okay, so we've got the mass of our solute going on the top, and our total grams of solution is 750 grams total. And notice I don't have to add them together because it was already added. That's why it says the word total, times 100. And so again, we do this in our calculator. We divide first. So 500 divided by 750 times 100 gives us 66.7% calcium phosphate. That's a lot of calcium phosphate. It's a very large percentage. And so that concludes pretty much the math portion of Unit 2. So if you have any other questions or you want to work practice problems, go on eClass, and you can find your independent practice problems there.